Good morning. Now, this is our class 3 of the chapter Experimental Methods and Error Analysis. Now, today we will learn about a few instruments that are used for measuring time. Okay, so before that, there are one or two paragraphs in your textbook that deals with a brief introduction about the early days of measuring time. That is how time was measured during early days before the invent of many such instruments used for measuring time. So I am not presenting all that here. That one or two paragraph you can read from the notes that I have already uploaded under the session module 3 of this chapter, experimental methods and error analysis. Okay, now here I will be presenting only the main topics. Okay, that is the various instruments used for measuring time right from the early days till present. Okay, now let's begin with a few simple instruments that were used during the early days for measuring time. One such instrument is the sundial. So, as the name indicates, sun. This instrument measures time depending on the position of sun. Okay. Now let us read this paragraph. Sundials have their origin in shadow clocks, which measures time depending on the position of the sun. Okay, as I already said, this instrument measures time depending upon the position of the sun or the shadow, or depending on the position of the shadow casted by the sun, just as the name indicates. Okay, now here a rod casts a shadow upon a plane surface, and this shadow is casted on a plane surface, and on this surface there are markings related to time, and it will definitely point out the time by judging the position of the shadow. Okay, all sundials are kept in such a way that their styles are parallel to the axis of Earth's rotation, because it is in that position that sundial tell us the correct time. Sundials are not used during cloudy weather or at night because the shadow casted by the sun will not be proper during these times, and it also requires recalibration when the season changes. Why? Because as season changes, the direction of sun will also change. So during change of seasons, sundials has to be recalibrated. So that's all about sundial. Next is the candle clock. Now in candle clock, the graduated candle was a means of determining time. That is, there is a candle and it is graduated. Graduated means it is marked. Okay. Now as these candles burned for few hours, each mark represented 10 minutes. So there is a candle, and this candle is marked, and each mark is graduated as 10 minutes. So 10 minutes, 20, 30, 40, and so on. Now these candles are placed on a wooden framed glass boxes. Then when the candle melts, the wax is collected periodically. Why this wax is collected? Because if it is not collected, it will interfere with the burning, so there will be an inaccuracy in the measurement of time. Okay, so there is a candle. The candle is graduated, uh, and it is each mark represents 10 minutes. Then it is placed on a wooden framed glass box, and when the candle starts burning, or it melts and the wax is collected, then the bottom of the candle is kept in a dish. Okay, then this candle clock, and so depending upon how long it melts, the time is determined, but the accuracy was limited. That is, it was inaccurate, so this candle clock was ruled out. And it is mainly used to tell in time indoors, especially at night or on cloudy days, because at night and cloudy days we can't use sundial. So at that time we'll be using this candle clock. However, the time measured by candle clock, the accuracy was very limited, and so this was no longer used even in the early days. So the use of this candle clock was ruled out. Now next one is the incense clock. Several types of incense clock have been found. The most common form include incense stick and incense seal. Here the term incense means fragrance or a pleasant smell. Okay, an incense stick clock has an incense stick with calibration. So when you say about incense stick clock, it will have an incense stick, that is a fragrant stick with calibrations with readings marked on it, and those markings actually stands for time. Okay, and sometimes these sticks will be hanged using threads with weights attached at even intervals, just like that shown in the figure. See, some weights are hanged. This is the top, and from there some weights are hanged using the thread like this. Okay, now the weights would drop onto a platter or going below, and if this, and it actually signifies the certain amount of time has elapsed, that is, it has got an incense stick which is graduated or with the readings marked on it, and each of these markings indicate time, and sometimes it will fall below inch by inch with the weights hanged on it, and how long it fall down will actually represents the time that has elapsed. Now, some incense clocks were held in elegant trays to allow the weights to be used together with decorative trays. So, here in the figure, you can see that it is a decorative tray. That is, the incense clock, stick clock is arranged over a decorative tray. So, just to add beauty to the clock, they are arranging it on some decorative trays and all. Now, incense sticks with a different scents, that is, with the different smells, can also be used, so that the hours were marked by the change in fragrance. That is, this incense sticks are available in different fragrance, and when there is a change in fragrance, it actually indicates a change in hour. Now the shape of incense sticks, it can be either straight or spiraled. Now the spiraled ones are longer and were therefore intended for long periods of use. Okay, and it is usually used in homes and temples. Next is the hourglass, which is quite familiar. You might have seen this hourglass. It is shown in the figure. It is also called by the name sand glass or sand timer, sand watch or sand clock. It has two connected vertical glass bulbs as shown in figure, and this allows a material fall from top to bottom. Usually it is sand. Once the top bulb is empty, that is, there is a top bulb and a bottom bulb. This is a top bulb and this is a bottom bulb. So once this top bulb is empty, it indicates an hour. Okay, then it can be inverted to begin timing again. So when the top bulb is empty, it actually indicates that 1 hour has elapsed, that is 1 hour is gone. And if you want to start the timing again, what you do, you just invert the whole apparatus, that is top to bottom, you will kept it as bottom to top, right, like that. You are just inverting it. Now, so there are certain factors that affect the time measured by this hourglass. Some of them are the amount of sand, then the bulb size, the neck width, and the sand quantity. Next one is water clock. A water clock is a clock in which time is measured by, as the name indicates, by regulated flow of water. There are of two types. One is inflow and the other is outflow. In outflow water clock, what happens is that a container is filled with water and the water is drained slowly. That is, water is taken out slowly and uniformly out of the container. This container has got markings which are used to know the passage of time. As the water leaves the container, an observer can see where the water level is with the lines and tell how much time has passed. So in outflow type, that is, you actually measure the water that is flowing out. That is how it is flown out, and once it leave the container has got marking, so you can understand how much water has left the container. So by noting that level, or by noting that level of how much the water has flown out, the observer can tell the time that has passed. That is the technique behind the outflow type water clock. Now let us know about the inflow water clock. It also works basically on the same way, except the only fact that instead of water flowing out of the container, what we you see here is the how much water is filling inside the container. Okay, that is the water is filling up the marked container. So as the container fills, the observer can see where the water meets the lines and tell how much time has passed. So that is the technique behind these two types of water clocks. In outflow type, we just look at the how much water has flown out of the container, and by looking at the marking in that container we can say how much time has passed. Whereas in inflow type, water is allowed to enter into the container, and finally we will note the level or the marking on the container up to which the water has reached, and from that we can tell how much time has passed. So that is the difference between inflow and outflow type water clocks. Next is mechanical clock. This is a figure for a mechanical clock. It works with gears. Gears are shown here. Now it has got two important parts. One is the mainspring and the other one is a pendulum. Mechanical clocks were wound with a key. As you know, they are mainly wound with a key, and this actually tightens the mainspring. Now when the mainspring unwinds, what happens? Its energy will turn the gear, and when the gear turns, it will cause the hands to move. That is hour hand, minute hand, extra hand all to move. The pendulum keeps time and ensures that the gears move at the right place second by second. So each of the hand moves second by second. Instead of mainspring, some of the mechanical clocks has got weight. Uh, Instead of gears, some mechanical clocks use various type of weights. Now mechanical clock do not need electricity to operate. They can run off of the energy generated by the springs and weights. So that's all about mechanical clock. You can just go through it. All these are very simple things. It's enough that you go through this one or two times, then definitely you will get the idea behind each of these clocks. Okay, nothing more to learn. Next is the pendulum clock. This I think you are all familiar, and so we will just read the paragraph. That is enough. It was a Dutch mathematician called Christian Huygens who made the first pendulum clock, and at that time it has got an error of less than 1 minute a day. Okay, after that, this 1 minute a day, that error was reduced to 10 seconds a day. Now let us see the definition for a pendulum clock. It is a time measuring device which uses a pendulum. That is, pendulum is nothing but a swinging weight as its time keeping element. So the pendulum is nothing but a swinging weight, and it is the time keeping element of the pendulum clock. So any motion or acceleration will affect the motion of pendulum. Now the time period of this pendulum is given by the formula T equal to 2 pi square root of L by G, where L is the effective length and G is acceleration due to gravity. Here the amount of weight and the amplitude of the swing has no significance. So it is possible to find out length of the pendulum to have a period exactly of 1 minute. Okay. Oscillations in the case of simple pendulum is limited to small swings, and nowadays the accuracy of simple pendulum is increased to 1 by 100th of a second a day. Next is quartz clock. Now quartz clock operation is based on piezoelectric property of quartz crystals. So that's an important point. The technique behind the operation of quartz clock, it's nothing but the piezoelectric property of quartz crystal. Let us see what is piezoelectric effect. That is, if we apply an electric field to the crystal, it changes its shape, and if we squeeze or bend, it generates an electric field. When put in a suitable electronic circuit, this interaction between the mechanical stress and electric field will cause the crystal to vibrate, and this vibration generate an electric signal of constant frequency that can be used to operate an electronic clock display. So here what happens is that here we are applying a stress. You have a quartz crystal and you are applying a stress that will produce an electric field, and now the interaction between this stress applied and the electric field generated will make the crystal to vibrate with a constant frequency, and that constant frequency is sufficient to operate the clock display. Okay. Now, quartz crystal clocks were better because they had no gears as the mechanical clocks or escapements to disturb their regular frequency. And now here the crystals that are used may not be of equal size with just the same frequency. So clocks and watches continue to dominate this market. This quartz clock and quartz watches etc. are dominating the market. Why? Because their performance is worth, and but the timekeeping performance of quartz clock has been substantially surpassed by atomic clocks. That is, once even though the performance of quartz clock is fairly good, now in place of quartz clock we have atomic clocks. Now what are atomic clocks? That is, an atom of hydrogen or cesium here today here today is exactly like 1 million years ago or in another galaxy. That is mainly used, these atoms of hydrogen or cesium can be used for making these atomic clocks. Thus atoms constitute a potential pendulum. In such clocks the only thing that act as the pendulum or the timekeeping element is an atom of hydrogen or an atom of cesium. Okay. Now the first atomic clock was built using ammonia by National Institute of Standards and Technology. However, its performance was not that much better, and some modifications were brought about, and some devices based on cesium was developed by National Physical Laboratory in England, and later they have made collaboration with US Naval Observatory in order to improve the performance of atomic clocks based on cesium. The frequency of cesium reference was established or measured relative to astronomical time. So that is just the theory or the background or the history behind the development of atomic clocks that I think you can read and just note down the important points, like the institutions that have developed the clocks or the institutions that put forward such calibrations and all. So the cesium's atomic natural frequency was formally recognized as a new international unit of time in 1967, and it's some specifications about the cesium is given, that is how much oscillations it has got, then how it is calibrated in terms of Earth's motions, like that. Okay, so this paragraph also you can just read through. Next is the digital clock that we use today. It is a type of clock that displays the time digitally, as we all know. Just the opposite of analog clocks, where in analog clock time is indicated by positions of rotating hands, right? Whereas in digital clock everything is represented digitally. Now digital clocks typically use 50 or 65 Hz oscillations of AC power or a Hertz crystal oscillator as in a quartz clock to keep time. Most digital clocks display the hour of the day in 24-hour or 12-hour format that you know. Then for a digital clock it needs a source of power to run the clock, an accurate time base which acts as a clock's heartbeat. Then it also need a way to gear down the time base to extract hour, minute, seconds, and a way to display on the time. See, here you got in digital session everything is represented individually, that is you need hour display, minute, second. Thus, it is clear that digital clock is identical to mechanical clock. It handles all mechanical functions of the pendulum clocks electronically. Next is about the standard world time. Now, the Greenwich Mean Time or GMT subsequently evolved as an important and well recognized time reference for the world. Okay, in the later part of the 19th century, a variety of meridians were used by various countries, but however, for a number of reasons, meridian was the most popular of this. Okay, now the only one factor in this popularity of Greenwich meridian is the reputation and the correctness of Greenwich Observatory. Now there is a, instead of Greenwich meridian, a prime meridian is also introduced, and some of the specifications of this meridian, that is prime meridian, is also given. That is how much latitude it is based on, or how much degrees of longitude, and various time zones that comes under prime meridian and all. So these two things are you must read through: Greenwich meridian and prime meridian, and just the differences. So nothing much to explain here, that's why I am leaving this paragraph. When you read this paragraph, you will understand the main point, so you yourself can prepare a note on standard world time. Okay, last one is Indian Standard Time. It is maintained by National Physical Laboratory, NPL, New Delhi, with help of cesium rubidium atomic clocks, achieving microsecond accuracy. Okay, it is calculated on the basis of this much longitude in Mirzapur, Uttar Pradesh, which is nearly on the longitude reference line. It also offers INSAT satellite based standard time and frequency services to users. So with this, we have completed the session dealing with the measurement of time. So here there is nothing much to explain. When you read through it one or two times, definitely you will understand the meaning, and all these are given in small paragraphs. So just go through it, read it, and mark the important points and learn. Okay, so that's all for today. Thank you.